Hello students, how are you? Hope you're doing well. Now the question is, the distance of closest approach of an alpha particle is small d, where it moves with a speed capital V towards a nuclei. Another alpha particle is projected with higher energy such that the new distance of the closest approach is small d by 2. What is the speed of projection of the alpha particle in this case? And the given options are option A V by 2, option B square root 2 V, option C 2V, and option D 4V. So this is the question which is based upon the nucleus and the alpha particle going with the closest distance of approach. So there is a formula used in this particular case that distance of closest approach, this is basically a constant upon the velocity square, the velocity of the particle and its square. So distance of closest approach is constant upon velocity square. So we have two different cases. In the first case, there is an alpha particle going with the closest distance of approach d, and in the second case, the another alpha particle is going with the distance of closest approach as d by 2. So we apply this particular rule. So according to the first case, we can say that the distance of closest approach is given as small d, and this is equal to a constant, upon the velocity in first case and its square. So this is the case 1. Similarly for case 2, small d by 2 is equal to a constant upon v2 square. This is case 2. Now we use this particular two equations. We use these two equations, equation first and second, dividing first equation by second. So we get 2 upon 1 d by 2 upon d, or we can say that 1 divided by 2, equation 1 divided by 2. So we get d upon d by 2 is equal to a constant upon v1 square divided by a constant upon v2 square. So this value comes out to be, this constants cancel, and we get this value as v2 square upon v1 square. And here we get this 2 goes up and d cancels to the d. So we get 2 is equal to v2 square upon v1 square. Now v1 square is basically v square, because in the first case the velocity is capital V. So we can say that v2 square is equal to 2 times v square by cross multiplying this and placing v in place of v1. So it implies that v2 equals to square root of 2v square, which is equal to v root 2. So we can say that the velocity in the second case is square root 2v. So we can say that option B is correct here. So this is the final answer. Square root 2v is the velocity in the second case when the distance of closest approach is d by 2. So hope you understand the solution. Thank you.